Good morning, everyone, and welcome to the next instalment of the Natilik Wednesday webinars. Today, we're going to be covering everything around SD-WAN, the public cloud, and the benefits it can bring to your business. Today, we have two experts with us, Danny and Jan, and they're going to be taking you through everything. So we can have a quick look at what we're going to run through today, and then I'll pass over to the guys. So first of all, Jan is going to take us through and give us a high level of SD-WAN and the Cisco SD-WAN solution. We'll then take a look into the public cloud and making it work for your teams, and also the challenges we're now facing with home working and how SD-WAN plays into there. We're going to just quickly recap on security and the managed services delivered with Natilik, and we'll have time as well to answer any questions you might have. So without further ado, I'll pass over to Jan.
So let's start with the why. Why SD-WAN? Why do we need to consider SD-WAN? So just as we have covered in previous webinars, and you can check those on Natilik's YouTube channel, there's an ongoing transition from traditional networking approach to intent-based networking. And what is more, it is a fact that software-defined technologies and automation are either already power or will soon be at the heart of pretty much anything that you can think of nowadays. So the wide area network is no exception to that. And in this section, I just want to cover the evolution of it and what SD-WAN has to offer. So initially, we understand that the digital business has evolved, and the modern workforce is increasingly distributed as the applications we consume are becoming more decentralized, moving from the data center to a multi-cloud environment. And that, when combined with the increasing number of users, devices, and locations that need access to cloud applications, this creates an overwhelming complexity for IT. So SD-WAN, in this sense, looks to come to the rescue of IT teams here. So SD-WAN is the application of SDN principles to the wide area network. And SDN is a centralized approach to network management, which abstracts the underlying network infrastructure away from its applications. So when compared to traditional networking solutions, which relied on integrated data control and management planes in the same platform, SDN decouples the forwarding plane from the control and management plane, allowing for decentralization of that networking intelligence. So this permits for more network automation, simplification of operations, provisioning, monitoring, and troubleshooting. So in simple terms, whereas before IT were managing WAN connectivity on a site-per-site basis and router-per-router basis, having to jump into the CLI of every device, SSH into it, and manually configure routing over available links, VPN between sites, and then if you had a new site, you have to create new VPNs for all of the different sites, so configure auto VPN, all that kind of stuff. And now what SD-WAN proposes is to do so from a central control point or orchestration plane that will take care of all the config in all the WAN edge devices for you. So in short, as indicated in the slide, the WAN has evolved from highly centralized and highly static to a distributed and dynamic infrastructure. Now the requirement is to connect any user on any device to any application and over any transport, and what is more, from any location. So let's see how we do it. Thanks, Heidi. So what are some of the SD-WAN benefits? Initially, we can define SD-WAN as a cloud-scale software-driven architecture that routes traffic around problems. It ensures application performance and adapts to changing conditions, all without the direct IT intervention. And in this slide, we summarize the main benefits. Increased bandwidth and through the activation of idle backup links and dynamic load balancing. And it allows to deliver faster cloud access by enabling DIA or direct internet access at the branch. It reduces operational and management costs by saving time to IT teams, not only during deployment, but also on day 2, for ongoing management and monitoring of the solution and easier troubleshooting. It reduces WAN costs as it enables the use of cheaper public circuits instead of private ones in non-business critical sites. Additionally, it allows for an advanced application experience that automatically evolves with the business strategy and the state of the network. It also provides a lot of flexibility without compromising on security, which is super important, as we know that a higher number of network entry or exit points with all of these DIA links and different locations only increases the attack surface. Finally, it can easily integrate with the LAN and DC domains to ensure an end-to-end policy compliance over any transport. So Cisco offers mainly two SD-WAN solutions. There is the Meraki Power SD-WAN solution, that is what Cisco describes as a pure play SD-WAN for simple and secure deployments at the scale and for distributed lean IT environments. There is the Viptela Power SD-WAN solution, which is our focus today, and that offers a greater scalability and greater flexibility of deployment on any routed network. So if you search online, you will find a lot of different information and views on what an SD-WAN solution should offer. Regardless of the bits, or regardless of the information that you find, the bits highlighted here in yellow are the ones that can be considered as the bare minimum features that any SD-WAN solution should offer. So it should do circuit balancing, ability to leverage DI connections securely, and it should have centralized management and orchestration, and it should have also transport independence and circuit cost savings. So additionally, Viptela SD-WAN offers extended features to ensure, as you can see there on the slide, a multi-layer zero trust security approach, application optimization, and we will specifically talk today about software as a service and infrastructure as a service optimizations, and app-aware dynamic routing. And finally, it is a solution that it can easily scale to cover all possible enterprise use cases that you may have. Here we see how flexible this SD-WAN offering is. So initially, I'm going to start from the top to the bottom, and we have that it can suit any sort of deployment. And there are options to deploy the main elements of SD-WAN either on premises or in the cloud, or as part of a managed solution with a multi-tenant deployment, with plenty of integration points and APIs available to make it easier to integrate with other systems. And it's also fully programmable from vManage, as well, some of you are probably aware, as you will see. It also allows for any service, and here more than anything we talk about the different use cases that can be enabled with SD-WAN. Branch and cloud security, which should really go hand in hand with every deployment, from my point of view. Application QoE to ensure that app flows are steered over the best paths available. There's seamless voice and call-up integration to ensure the lowest latency and minimize jitter for these real-time traffic flows, and cloud on ramp, and we will see afterwards, to simplify that transition to the cloud. Then we have that it can work over any transport. SD-WAN really does not care about the underlying transport, as it automatically builds tunnels and sends traffic over any technology. So there is flexibility to select up to 9 active or backup uplinks per edge route. And the overlay tunnels can have either full mesh topology, a partial mesh, and hub and spoke, and all of that per VPN overlay. So per virtual SD-WAN fabric, you can decide how you want your traffic to be routed across your WAN. And then finally, as we were talking, any location. So home, as we'll cover later, and that is now a hot topic, or branch or colo and cloud. It doesn't matter. There are different endpoints and edge devices to ensure the flexibility to connect all of these locations, regardless of what is your end-to-end deployment. So with this one, I just want to cover the main elements. So the SD-WAN solution is broken up into 4 planes. data control, management, and orchestration. And firstly, we have the Cisco vManage, which is the management plane, and it represents the user interface of the solution. So network administrations and operators perform config changes, provisioning, troubleshooting, and monitoring activity here. So it offers both a single tenant dashboard and a multi-tenant dashboard for a variety of customers and services provider deployments. Then we have the Cisco vBAN, which resides on the orchestration plane. And the vBAN controller is largely responsible for the zero-touch provisioning process, as well as first-line authentication, control management, and facilitating the network access and translation transversal. So more than anything, this is the main point of contact for those VH routers when they boot up for the first time. They will contact the vBAN, and the vBAN is what will allow them to connect to your SD-WAN deployment in an easy and sort of plug-and-play way. And that's quite an important part of the solution. And you have the Cisco vSmarts. We can say that these are the brains of the solution, and they will exist within the control plane. And what they do is they're responsible for enforcing the policies centrally. So when branches come online or new devices come, the routing information is exchanged with the vSmart controller and not directly with other branches necessarily. So by using policies that you can configure from the vManage, the routing information is influenced and shared with the other locations, and that in turn determines how individual branches will communicate with each other. So the routes are then shared and received by the overlay management protocol. The vSmart controllers can invoke the policy created on vManage against these routes and control how traffic traverses the SD-WAN fabric. Then the other element that we have there is vAnalytics, which we can say is like the assurance part of Big Tela's SD-WAN solution. So it is a cloud-based service that offers insights into the performance of applications and the underlying SD-WAN network infrastructure. It offers the following details over an extended period of time. So it offers network performance, and it will give you details such as uptime and key performance parameters of your data, and that includes latency, loss, jitter. It will also give you application performance. So it will tell you the top applications and the bandwidth that they are using, the quality of experience of them. And what is more, it will hold all of these data and show it to you for anything ranging from a day through a week, a monthly view, or even a custom period of time. It can hold data for up to a year in total. And then finally, we have the WAN edge routers, that are the actual responsibles for establishing the network fabric and to forward the traffic from your WAN edge or within your local area network, or if you are at home, and then from that border between your home and the WAN. So all of these components combine and is what make a Cisco SD-WAN solution. So I think it's worth noting that most of Natilik's SD-WAN deployments are cloud-based, unless there are very specific reasons to avoid that. What it means is that although it is important to know that all of these elements are on the hood of this solution, most of them are transparent to you and are dealt with completely by us when setting up the solution. vManage and vAnalytics as the user interfaces, and VH devices that connect to your WAN circuits at the WAN edge are the elements that you will probably have direct access to and you will probably get to play with the most, depending on the managed service tier that you get from us when setting up the SD-WAN solution. I think this is all I wanted to cover as a brief overview of SD-WAN. So please remember that we're available to arrange sessions on any SD-WAN specific topics on any technology really. From the very basics I just covered, but in a bit more depth to anything very specific. So please reach out and we will arrange accordingly. We're working hard to increase the amount of content that we upload. So please also subscribe to our Natilik YouTube channel if you haven't done so. And that's it. That's all the quick theory and summary overview I wanted to cover. Now we'll hand over to Danny to follow up with our main topics for today. Thanks again.
Thanks, Jan, and good morning, everyone on the call. So we're going to firstly touch upon the public cloud and in specific SaaS optimization. So if you just drop to the next slide, please, Haley. So I suppose it's worth just discussing like how it sort of is for a lot of companies and businesses currently. So you know, you may have multiple remote sites, branch offices, divisional sites, which need to obviously access the internet. And you know, typically you'd sort of backhaul that traffic from a remote site or branch office to a regional data center or colo, and you know, you'd break out essentially from there. You know, maybe over like a private MPLS or sort of VPLS circuit. And typically, you know, traffic had to be filtered and sort of passed through that security stack, sort of firewalls, IPS, etc., which tend to live in the data center. You know, from a sort of the connectivity point of view, people tend to you know, like the sort of whole MPLS quality of service and the sort of guaranteed SLAs that come with that, especially when you compare that to sort of, you know, SLAs of the internet. And then, you know, companies didn't really want to have to sort of set up a security stack at each of these remote sites or branch offices, because not only from a sort of hardware and licensing perspective, it becomes very costly, but from a sort of operational cost as well, having to maintain, you know, a lot more hardware and infrastructure in your network, you know, sort of doing all the patching, any troubleshooting, etc. So, you know, that does tend to add up. So, you know, sort of why change things now? I suppose we're all aware that, you know, DCs have evolved. Not all the resources that we consume as a business is on-prem. So, you know, looking at SaaS applications specifically on this slide, for people in divisional offices to access those SaaS applications, you know, we're still having to sort of backhaul that traffic to the data center and out. It's not an effective use of that bandwidth. You're also adding, you know, an extra hop in there. You're utilizing expensive MPLS links. And I think off the back of the COVID situation, especially, what we've heard quite a lot from our customers is that, you know, people have said that the internet just works. You know, people may have been able to sort of crack on working from home and, you know, join Zoom meetings, WebExes, and everything's worked so far. So the Cisco SD-WAN approach and how that sort of, and you know, their vision and what they can do to sort of help, you know, reduce the costs of MPLS whilst also optimizing the application performance for the end user is for cloud or remote for SaaS. So currently vManage has 13 defined SaaS applications sort of out of the box. Talking like the big guns like Office 365, Salesforce, Dropbox, Concur, you know, those ones in there. And if you can see, if you take this example in the slide, so the remote site we see here has a direct internet access, you know, breakout locally from that site, and it can obviously go to straight to the internet, and it also has that link, sort of the dark blue one covering green, going to a gateway, which could be you know, data center or, you know, regional office, for example. So to sort of optimize that behavior and performance of that application, if you have traffic within your divisional site that, let's use Office 365 as an example, that needs to access Office 365, within vManage you can say, okay, if any traffic comes in destined for Office 365, I want you to probe my all of my transport links that I currently have to ascertain which is going to give the best experience based on, you know, loss and latency of that link and how that application is performing. So from the remote site over the DIA link, it's pretty much just like an HTTP ping. It pings like an Anycast gateway of Office 365, and it will get those loss and latency figures back. The difference going via like a data center or a sort of regional hub is because by default out of the box, the SD-WAN fabric runs BFD. So BFD polls every 1 second between all the devices. The sort of the resulting score of like, you know, is going via the gateway going to be better than DIA takes into consideration, you know, the BFD score plus the HTTP ping. So they call it the VIT quality of experience. It's a score out of 10. If anyone is interested after the call, I can share like the formula and the summary of how they get to a figure out of 10 based on, you know, the looking at loss and latency and jitter. So please just give me a ping afterwards if you don't want me to share it with you. But there's basically like 3 bands: 1 to 5 being bad, 6 to 8 average, and 9 to 10 being good. So based on that score, traffic is automatically directed to the best transport that is available to reach that SaaS application. Next slide, please, Ellie. So this is just a brief like snippet from vManage, and it's just basically showing like the VKOE scores. So in this example, you know, we've got the top 3 are got a VKOE score of 10. The DIA status is local, obviously meaning that it's got local breakouts to the internet, and you compare that obviously to the 4th one, which is got a VKOE score of 6, but the DIA status is gateway. So obviously that's going via the gateway or data center first, and then from the gateway, that is where you're doing the HTTP ping out to the SaaS application. Next slide, please, Sadie. So looking more at the IaaS optimization side of things is, yeah, obviously a bit more in depth. One of the benefits that Cisco have done with their SD-WAN solution for infrastructure as a service in the public cloud is that ability to, you know, extend your SD-WAN fabric into the cloud. So in essence, the public cloud becomes an extension of your fabric, of your network, akin to you know, spinning up maybe making an acquisition or taking lease of a new building, and you need to get that building on the network. It's sort of similar to that. You know, that public cloud is just then part of your network. And the result of this is that from vManage, that central dashboard that Jean touched upon earlier, you know, you can apply your common attributes to on-prem and the public cloud, So, you know, access policy, security, quas, segmentation, application-aware routing, traffic steering can all be done, you know, via the vManage, and you know that takes effect in a public cloud as well. And what's clever as well about them, obviously, it's only quite recently, the past couple of releases of SD-WAN code, is about the automation that can be done within vManage to actually spin up your cloud instances. So, you know, some companies might not be au fait with cloud technologies and the constructs, and, you know, they're sort of just, you know, getting to grips with it or just starting off, but, you know, want to, you know, leverage the investment in SD-WAN into the public cloud via vManage, and we'll show this in a pre-recorded demo next, is the ability within about 5 minutes to create those constructs in the cloud. So if we look at the diagram, for example, there's an Azure and AWS example. In the transit VPCs or the transit VNet, it is basically where a couple of the cloud SD-WAN routers get spun up. And those constructs there are all done via vManage, so you don't actually have to go to like AWS Marketplace and look for the AMI and, you know, apply the license and spin it up yourselves. Utilizing the APIs of the cloud, of the public clouds via vManage, that's all done for you. And not only that, but, you know, the actual routing from those transit VPCs to your host VPCs or your host VNets, or basically where your workloads reside, that routing is already done for you via the vManage APIs. So a lot of the work is actually sort of abstracted for you, which can be good depending on, you know, obviously the skill level of the cloud, or you know, how much you actually want to do yourself. The Azure example, it differs slightly, because what we've found in Natilik doing this is that, you know, some companies, like I said, don't have a great deal of cloud knowledge or cloud team, and want to sort of like offload that to, you know, a third party to manage their sort of cloud environment for them. And we've come across where, instead of peering directly from the transit to the workload subnets, or the workload VNets or VPCs, we actually peer with like a hub. So in essence, you know, in the Azure example here, the transit VNet will learn the routes for the workloads in the spokes, we call them here, via the hub VNet. But it's the same principle. So So again, like looking at the branch site in the diagram, it has two links, has an internet and MPLS. Obviously, MPLS, we say go to the data center, and data center has either direct connect or express route. Now, the visibility that you have of the link here runs really from your routers in your branch site to the virtual routers in the cloud. So you'll be able to see that sort of, how that link is performing, like in terms of lost latency and all that kind of stuff, and utilization of that link. But obviously, what is abstracted away from you is sort of anything in past that into the cloud, because the SD-WAN routers, the virtual ones in the public cloud, are your demarcation point. That's the end. Everything past that is to do with the public cloud. So what Cisco are working with Microsoft to begin with, and the sort of a deal and a partnership with this is, using the APIs of the public cloud within vManage, you are going to soon be able to see the whole end-to-end performance statistic metrics of that network, from your SD-WAN router right to your host VNet. So you'll be able to actually see end-to-end like what the performance is and look at all the statistics. There's no date for that yet. They hope to be able to do the same thing for Azure, but for AWS, but it will be coming into Azure first. I think that's what I have to say on that one. Yeah, thanks, Haley. So I didn't have the min rules to do this live, so I just recorded it. So let's see how this goes. If you could press play, Haley. So this is the dashboard. As you can see, we've got 6 WAN edge routers which are up in the dashboard. And this is obviously just the initial window that you come to when you log into vManage. See the sort of like statistics and information about the network.
I think, Danny, it might be that we have some of our attendees who have also joined separately. So I'm not sure if I pass you the ball for the presentation, if you have the pre-recording on your computer to share your screen.
Yeah.
We can make sure everybody can see.
Yeah, 1 second, let me see this.
It's always the way when you are doing a live webinar with the demo demons, as we call them.
Yeah, and this is why I pre-recorded it. Right, so I want to make sure I've got the right one. I think it's this. Okay, have you passed the ball?
Yeah.
Okay, so let me know if you can see that.
Yeah, perfect.
Okay, so right, hopefully this will work, and hopefully everyone can see. If not, just please shout. So yeah, like I said, so here is the SD-WAN dashboard. We go to Cloud on Ramp for IaaS. So as you can see, obviously nothing has been configured here at the moment, and we can click on New Cloud Instance and select the public cloud. So this is where you will enter your details of your actual account within the public cloud. Obviously, this needs to be set up prior to actually doing this. Cool. So as you can see on the right-hand side, you have a very sort of high-level, grayed-out type diagram, I suppose you can call it, and that will get populated and made more colorful as you go through the steps. So the first one obviously is to select a location for your transit VNet. So go on to UK South and just enter a couple of details about that transit VName. Even though I did this on a pre-record, I still couldn't type properly. So select a version as well. And so just to pause it here, the two transit WAN edges that you can see here, F4 and F8, obviously is the size of the compute. The real difference there is about like the maximums, shall we say, that they can handle. So the key ones being number of IPsec overlay tunnels, ARP entries, OMP routes in the overlay, IPv4, and DPI flows. I mean, the F4 is actually quite substantial in terms of like what it can handle. But if anyone would like the specifics about the differences between the two, obviously just please shout and I can share that with you. And again, just here we can see this is the actual dcloud demo, which I sort of use. So you can see it's got like an example for AWS here. But prior to you can actually create the templates for the cloud routers prior to spinning up the transit VNets or VPCs. So using this declouded devices are already there. But yeah, you pull a license down for those virtual routers, you create a template for it and assign it to that. So when you do this cloud on-ramp for IaaS, you actually have those routers to select. So select the tier ones for Azure. Advanced here, you can see it's just a transit subnet for that you enter there. So go to discovery and mapping, and you can see obviously now the bottom bit is now green because it's got the VH devices and transit VNet. This is obviously linked to your account in Azure. So obviously your credentials here will display what accounts that you have, and as a result of that, depending on what account, what VNets that you have in terms of your host ones, so your workloads. And now you can see the host VNets have been discovered at the top in green, and click to the next one here. And then you want to map that transit VNet and those host VNets together. So this is where it's into some information around addressing for the IPsec. So this is from the transit VNet going down to the host VNets. Like I showed in the previous diagram, it uses BGP as well to get into an ASN and the host VNet gateway subnet. Give along that a bit. And there we go, everything's 3 ticks and green, looks pretty. And then it goes off and it actually starts building those constructs in the cloud. So what I didn't realize was I had to keep pressing refresh. I thought it was going to actually automatically do it for me. So I will skip along, otherwise we'll have watching paint dry. But yeah, so as you can see, it creates the VPC, it creates the subnet that you assign to it. And it's there spinning up the VH pair within the transit. You can see that it's finished creating the transit VPC. Specifying, just confirming the region and mapping the host VPCs in your account to that transit VPC that you created. And then here we've got setting up the IPsec VPN and BGP configuration. Let's skip along, and then it's done. So if we then just go, I think I just went back to verify this. Yeah. So if we then go back to the cloud on-ramp for IaaS, we can now see that we've got one mapped host VNet and one transit VNet. And looking at the host view, confirm here that we've got Azure, UK South, and the transit VNet there. I don't know if there's the map transit VPC using the cloud, whether that's just a standard thing or whether the actual sort of example or lab here that should it be VNet, or that's just a mistake. But the point is obviously it's been pulled through and created. And when we go back to the actual main dashboard, we can see now that the number of WAN edge routers has increased by 2. So we have now 8 WAN edge routers, and clicking into that, we can see that we've got the 2 Azure vEdge routers have been configured. So I think all in all, this is about, I think it's about maybe 4 or 5 minutes, yeah, 4 minutes 19 to do that. And those constructs that were shown in the diagram in terms of like the transit and that connectivity to either your host VPCs or host VNets is all now done via vManage. That's it for the demo, Haley. So you can take it back if you so wish.
Brilliant, thank you, Danny.
How am I doing for time as well? Am I good?
Yeah, you're all good.
All right. So let me close down this. Okay. So that was a sort of quite like high level about SD-WAN and public cloud. Obviously, any questions, please let me know. But the next thing I want to talk about is the home working solution for SD-WAN. Thanks, Haley. Next slide, thank you. So this is quite recently released from Cisco. They call it the Teleworker or home working solution with SD-WAN. And as a result, it sort of was born out of the increased demand for home working as a result of the situation we all find ourselves in. It's based on the ISR 1Ks. And the sort of key to this is, much like public cloud, when I was talking about making the public cloud an extension of your network by putting some virtual SD-WAN routers and enabling to have common policy throughout your on-prem and obviously a public cloud. The same thing is with this home working solution. You're extending your SD-WAN into Fred's house, into Mary's house, and consistent policy again on branch, cloud, Mary's house. So the key thing here is that the simplicity of the home working solution. So very briefly, like when I don't know, let's pick another one, Jane decides that she's a home worker and she needs to have connectivity. Your business has gone down this SD-WAN solution, you've adopted public cloud, you want to make sure you get more investment and keep that consistent policy throughout your WAN, so you go for this teleworker solution. The device serial number of that ISR gets added to your smart account. The serial number is available in the PMP portal, which vManage downloads that serial number. And then from there, you'll be able to pre-provision the templates for Mary. So you might have a consistent home working template with consistent policies and the routing and reachability that can all be configured within a base template. And then Mary gets the router shipped to her house and powers it on and provides WAN connectivity. So, like an RJ45 into her existing router. The router will get a DHCP address, contact the vBond. vBond will say, yeah, I'm authenticating you. Your serial number makes sense to me. Yeah, the whitelist has been, acceptable. It's all been configured. I'm happy to sort of tell the vSmart that we're good to go. So after that, that's obviously in this diagram, number one, router. Number two, then vBond okays that. Then after that, the vManage is allowed to push that configuration template down to the ISR. And then as a result of that, you have that consistent policy. Mary is now part of the network as if she was in the office. So it's a way of obviously via that vManage provisioning remote networks at mass scale and that consistent corporate policy at home, and also the visibility and management that you gain from the vManage controller as a whole. So and within those ISRs as well, they have an access point for wireless connectivity. It's an AP, it's an 1800. Default ships in Mobility Express mode, but as part of the templates that you have via vManage, you can use a DHCP option 43 to convert that AP into CapWAP and push it to the WLC in the data center to get managed, and then can be run in Flex Connect mode for local switching. Now, I did say contact the WLC in the data center. That is true, but you can also leverage the new wireless LAN controllers 9000 series in the public cloud. So if you are moving that way and you are shifting things to the cloud and you have your wireless LAN controller in there, this option does work with the public cloud as well. Now, connoisseurs amongst you might notice a little bit of a sort of similarity to Office Extend. Yes, that's a good spot, and it is quite similar. But obviously, comparing to the sort of older generation or older deployments of OEAP, you don't have to leverage a dedicated wireless LAN controller to use this. You can just use the same one that you do for your on-premise solution. So yeah, then as a result of that, you'll have your corporate SSID pushed down to the AP to the router, but also a separate guest Wi-Fi network for non-corporate traffic, basically, for everyone else who's living at home to use. And again, with this solution, with the fact that SD-WAN is now pushed to your home workers, you'd be able to leverage all those cloud on-ramp facilities and capabilities of SaaS application, and obviously, into the public cloud as well for your IS solutions. Thanks, Saley.
Actually, Danny, before we move on from this slide, a question has just pinged up. I thought it might be good to ask whilst we have it in front of us. We have a question. I understand the ISR enclaves need to have the basic IP config to reach vBond to authenticate. Is this right? Are we using any automated way to work with initial authentication, or do we do it manually?
So once the ISR obtains an IP address and it has that connectivity, that's why sort of DHCP needs to be configured in order to have that to the router be able to get an IP address. then it will just contact. It will use it's zero touch provisioning. I can't remember what this is like zdp.victor.com, but there's a Cisco one as well, and it will automatically go off and speak to VBond. So the whole there was, when I was talking to Cisco about this and just understanding how like the configuration would work and maybe the setup at home, I thought, well, is it going to connect into your existing router? Are you going to just utilize maybe like the ADSL connectivity on the ISRs and go directly into there? But then it wouldn't really work, and it's not really zero touch, because you have to then get all of like the POE information from the service provider and configure that on the router. And then a lot of people don't have like the technical depth to sort of log into the router and do that configuration. So Cisco's stance for this is it would connect into your existing router, get an IP address, and from there the ISR will automatically contact the VBond.
Brilliant, thank you.
If there's anything further on that, then yeah, we can have another discussion about that maybe after the webinar, if I didn't answer it. So yes, security of SD-WAN. I thought I didn't want to not talk about this slightly. Just a brief caveat from myself. I'm not a security expert by no means, but the integration with Umbrella in SD-WAN is becoming tighter. If you just go to the next slide, please, Ellie. So I just wanted to literally just a brief one slider and to say that the integration is there. The consistent policy, whether in the office or home, Starbucks, is a key thing that people want to have. We ourselves at Natilik utilize Umbrella. I myself, very rarely log on to the VPN anymore, but the policies that the company wish to adhere to or wish to create are pushed down to the laptop, everyone's laptop. So there's certain, obviously, the key types of websites that you can't access, etc. And you have that security whether or not I'm going into Starbucks, for example. I don't have to use the VPN. The ability to sort of register Umbrella as a SIG is within vManage now, so that integration is slowly becoming a bit more fluid, shall we say. And I think just want to cover that the main elements really for the Umbrella solution are obviously the DNS lookup that was there from day one, but they're sort of like cloud delivered firewalls and web proxies now are all sort of integrated with Umbrella and can all be used as part of an SD-WAN solution. So I didn't want to just not mention the fact that security was important for SD-WAN, because obviously it is, and the integration with Umbrella. But if there are any sort of more dedicated questions around the integration with SD-WAN and Umbrella, then please let us know, and we can either set something up or speak to some of our dedicated security architects about that one. Thanks, Ellie. And then just to finish off, lastly, just about the sort of managed service and levels of support with Natilik. So, as I'm sure like most of you are aware, we offer like a sort of 3 levels or 3 different types of managed service that are managed by you, with you, and for you. And I think with our connectivity practice that we have in place within Natilik, we've got a sort of a good story to sort of like a good wrap around like the SD-WAN. So not only do we actually provide hardware licenses, we've got that connectivity in place as well. And I think having worked at a service provider before, it's not a case of like having to hand over the keys to your WAN to a service provider where you sort of you lose visibility or control in regard to making changes to your network. We're sort of very much here to work alongside you and support you on your journey to SD-WAN. And I think with that, Hayley, I'm done.
Brilliant. Thank you so much, Danny and Jan. That's been really informative. And we have had a couple of questions ping up whilst we've been going through, so I'll quickly run through them. The first one was on the IaaS, if I'm saying that correctly, diagram showing Azure and AWS. Is there currently support for GCP?
Yeah, it's a good question. So currently we're on version 17.3 of the code, and that got released in August. 17.4 is out in November, and that's when there's going to be support for Google Cloud Platform. it's going to be coming as a bring your own license to start with. By that I mean that sort of like API driven model that we demonstrated in the video won't be there from day one. It will be more of a manual process, but support's coming 17.4, and I would suspect the release after that would hopefully see some more of the automation.
Okay, and the next one is kind of a worst case scenario. What would happen if the vBond orchestrator and vSmart controllers all died?
Yeah, it's quite quite a niche one, that, because obviously they're in the cloud, and you know, they can be spun up if there are failures. But say if there was, for example, a massive failure, then the data plane won't stop, so your routers won't stop working. That communication between your vSmarts and the routers will obviously be lost. Now, during the sort of configuration process, you set up your maximum duration for your key rotation. So basically, you know, every so often the vSmart has to talk to the routers in order to make sure everything's okay and working correctly. So it's basically, if you lost the connectivity, the rule is it's the half-life of your key rotation. So if you set your key rotation to 7 days, you have 3.5 days before your routers will stop working. So I think it's quite a long time, but yes, that was what would happen.
And this might be a little bit more of a commercial question, but how does the licensing work for teleworker deployment? Yeah,
it's a good question, because our licensing is quite obviously like crucial for SD-WAN. So just on normal deployments, like for offices, etc., you would say, okay, well, I've got, you know, like a 1 gig bearer, but I want to cap that at 500 meg, and I'll have like a 500 meg license, for example. What Cisco done with the teleworker is they've sort of removed all of that, so your limitations of your bandwidth that you can achieve are limited by your current ISP. So there's no specific licenses or capping from a sort of Cisco SD-WAN perspective for teleworker.
Okay, perfect. And one more question which has come through. Is there support for third-party integrations, mainly around the security piece?
Yes, so SD-WAN does work with Zscaler. I'm guessing that might be one of the ones the question might have been leaning towards. Within vManage, not yet. So within vManage, you can only select Cisco umbrella as the SIG, but Cisco SD-WAN solution does indeed like work with Zscaler, but the sort of type integration isn't there yet. Whether it will come, not too sure. If I'm being honest, I can sort of maybe politely ask Cisco and see if there's going to be any movement on that, and let you know. Brilliant,
thank you. Okay, well, thank you so much for the session today. And if anybody has any questions following on from what the guys have covered, please feel free to reach out and we can arrange a session for you. And the recording of this session will be live on our YouTube channel if you want to recap on anything that was covered. Thank you very much.
Thanks all.
Thanks, everyone.